In this video, we're going to consider electricity. Let's think about a short story. Imagine it's a cold winter's day and the air is really dry, and you happen to be wearing a polyester shirt. If you move around, your body's going to build up charge. In fact, if you move around in just the right way, you can build up enough charge to zap someone. Let's not consider the consequences of this action for a moment. What's happening there is that there's a difference in charge between your body and the other person. Now, that difference in charge between these 2 points, that's potential difference. And nothing happens until you bring your finger close enough that the charge jumps from you to the other person. This difference in charge between 2 points, that's called potential difference. Now, potential difference is measured in volts. An important thing to remember about voltage is that voltage isn't the measurement of any action, it's only the measurement of a charge. Now, when we get close enough to touch the other person, something happens. This charge moves. Now, when voltage moves, something happens. And that thing, this motion, is measured in amps. Amps is the movement of charge. So if charge always wants to equal itself out, if places of high charge wants to dissipate to areas of low charge, why doesn't that happen all the time instantly? That's because charge can't jump magically from one place to another. It has to move through something. Different materials allow charge to move through it at different rates. Some materials will allow charge to move through it really well, while other materials will barely allow charge to move through it at all. A material like metal will allow charge to move through it very well, where a material like plastic will not allow the charge to flow through it very well at all. A material that allows the movement of charge easily is said to be a good conductor, and it has very little resistance to the movement of charge. And a material that prevents the movement of charge is said to be a good insulator, or is said to have a very high resistance. The ability for a material to either conduct charge or insulate against charge is called resistance. So let's think about this a little bit more. If there's less resistance, then more current is going to try and move. And if there's more resistance, less current is going to try and move. It is the resistance and the size of the charge that determines how much current can move. And that's what Ohm's law is. Ohm's law says that there's a relationship between the voltage, the resistance, and the current. I like to think of Ohm's law like this. If the voltage stays the same, as the resistance goes down, the current goes up. So in the world of electronics, this is something that you have to remember. As the resistance approaches zero, the amount of current that will try and move will approach infinity. Now, you can't have infinite anything. Take this piece of wire. The resistance of this is nearly zero. So the amount of current that could try and move through this piece of wire could be nearly infinite. Now, you can't have nearly infinite anything. So something's going to break. Maybe the piece of wire will melt, maybe the power supply won't be able to give so much current, but something will break under these conditions. This is why we have to introduce some resistance in our circuits. You have to put some resistance to limit the amount of current. Well, thanks for watching, and I hope you've learned something about what electricity is.